Why did not one of your kids come to your meeting?
They're busy. Mm-hmm.
There we go.
Okay, hello everybody. I wish you guys were all here. I just baked some blueberry muffins. Sure would like to give you guys all a blueberry muffin this morning. But my son Cohen is telling me to stop. They're all for him. So maybe it's a good thing. I can't give you blueberry muffins, but they do smell good. Okay, Cohen, you can come have a blueberry muffin now.
Okay.
Careful because it's super hot. Well, thanks for joining, everybody. It's good to see all of you. Today, I want to walk you guys through some planning processes to help you get started on the Create Performance task. I actually have a lot of documents for you guys. I've been trying to post stuff in Google Classroom as much as I can. They're just resources. They come from the College Board. The idea is to give you some guidance on what are you supposed to make and how do you know if what you made is good enough. So the first thing I just want to mention is the Release Readers Report. So I don't know if you guys saw that already. I'm gonna open it for you and show it to you on our screen. I'll do just a quick screen share. Make sure I admit everybody first before I leave out of here so everyone can come in. Is everybody in? Okay. This is the first thing I want to show you guys is this. So in Google Classroom, under the Create, one of the things that I put in there was this grading report. What happens is all of the graders who grade all of the performance tasks, remember we talked about, like, you know, whatever, 100 teachers sitting in a hotel room for a month grading these. After they get done grading all of them, they release a report. It's actually a ton of great information for you about how they grade, what they want students to work on, where students are making mistakes. So if you click on this, here's the number of students that were scored. So this is from last year. So you got 72,000 students submitted these performance tasks. They had 500 readers. And some of you were asking about the score distribution. It is a forced distribution. I don't know if they'll do the same thing this year as they did last year. My guess is yes. So maybe do be paying attention to these distribution numbers. So they're going to give 14% a 5, about 21% a 4. Notice that the majority of people got 3, and then of course the global mean score was a 3.1. But again, that's still passing. That's still going to get you your AP credit. These were the scores for the different criteria. Row 1, row 2, row 3, row 4, as we've been talking about. And here are some things like what were the responses to this question expected to demonstrate? So sometimes I think that when they ask the question, you're not really sure, like, how well do I have to answer this question? And I would encourage you to read this through. You need to answer that question thoroughly enough to convince this grader or this reader that you have the ability to design and create a program that has a particular purpose. Or for algorithms, you're expected to demonstrate an understanding of how to develop and implement an algorithm in a program. In particular, students are expected to recognize and use algorithms as building blocks. So when I was reading through your write-ups that you did for Pong, one of the things that I really tried to convey to you as I was giving you feedback, and this is very similar to what we did for the Explorer, make it very easy for the reader. This is an algorithm because, right? And we talked about how there were 3 things that made something an algorithm: sequencing, selection, and iteration. So if they're looking for you to recognize an algorithm, make it really obvious that you can. This is an algorithm because it uses selection. It's an algorithm because it's dependent on sequencing, or because it uses iteration, whatever those things are. Make it easy for the grader to quickly give you that point. Oh, this student absolutely knows what an algorithm is. They're using the definition of the algorithm right here in their response. They wanted you to highlight a code segment that implements the algorithm they developed that uses math or logic. So again, make it really easy. The way this algorithm uses math is, the way this algorithm uses logic is, one way math or logic were introduced, math or logic concepts were introduced in this code is, and spell it out for them really clearly. Students are expected to explain how the algorithm functions and describe what it does in relation to the overall purpose. Some of you wrote things like, this algorithm bounces the ball, or this algorithm runs the paddles. That's probably not enough. So you would be looking for something like, this is an algorithm which uses selection to determine if the ball is close enough on the right-hand side or the left-hand side of the canvas to see if it needs to bounce off either the paddles or fall into the gutter. So be really explicit in the way that you talk about how the algorithm works. Something else I wanted to share with you from the report is they actually break down for you common misconceptions or knowledge gaps for each one of the responses. And then they give you some guidance on what would it look like to have a really high scoring response. What would that be? So just looking at question, let's go to question 2B, because a lot of you asked me about this already. And the 2 graded samples that I gave you, both graded sample C and I, both of those samples missed row 2. They both missed the point for row 2. It should be easy to get points for row 2 because all you're doing is writing about your the time that you spend developing your program. Like, how do you actually write it? So here's the misconception. Students miss this because they wrote about the time they spent brainstorming ideas. The College Board doesn't want to hear about all the time you spent brainstorming ideas. So if you said, first I thought about doing this, but then I changed my mind and I decided to do something else, that's not what this is supposed to be addressing. So instead, look at the description for a high scoring submission. Describe the overall development of the program. That might include, how did you design the user interface? So for instance, is there a welcome screen? Is there some graphics at the beginning? Did you include some instructions on how to use your program? Is there a way that they give input or put their name in? What does it look like when the user interfaces with the program? You can also talk about how you wrote your algorithms. Which algorithms did you write? How did you know which ones you needed? So when we were writing our partner programs and I asked you guys to build sort of like an outline, just using pseudocode, just saying, well, I know I'm going to need a function which does this. I know I need a function which does this. And this is what I need these functions to do. That planning process where you're thinking through which functions would you need, what would each one of those functions need to do, or what role would they play in your overall program? That's what you're talking about in row 2. It's just how you built, designed, and thought about your overall code. It's not your ideas, it's the actual coding that you're doing. And then in row 3, this is where you're describing the code that isn't functioning properly. Did you identify errors and did you resolve them independently or by working with a partner? That's like the difficulties and or opportunities. You don't want to talk about the difficulties in what type of program to create. Like you don't want to say your difficulty was you couldn't come up with an idea. The difficulty actually needs to be difficulty with programming code. And then you also need to talk about what was done to resolve the difficulties or incorporate opportunities. So here's a person who says, I used a debugger to determine that my loop count was off by 1. So the debugger could be that it prints to the console log as a way of checking to see if it's working or not working. We tried that a little bit with Pong. You can also talk about that you had an opportunity to enhance something, and then it's like, well, you had this idea, like an opportunity. Like I saw that it wasn't updating the score every time, and I thought that I would make it update it more often. And so this is actually how I changed the code or improved my game to do that. That's different than like the development of the program. The development is when you're initially creating it. Row 3 is about once you've kind of created it, what problems did you run into? No one writes code perfectly the very first time, ever. So they want to know, what did you change? What did you enhance as you went along? Other good stuff that's in here, they talk about some advice. What advice would you offer teachers to help them improve the student performance on the exam? For submission requirements 1 and 2A, there's some really, really, really good advice in here. We've spent a lot of time talking about how to become familiar with the requirements. When we made our Pong game, right, we explicitly talked about the complexity of the Pong game allowed us to have an algorithm that contained 2 sub-algorithms. And then we were trying to write about that, right? So we were practicing that. Other stuff that's in here, ways that you can be prepared to answer those questions better. And you can read through these. So the other thing that I gave you were the graded samples, graded sample C and graded sample I. Thank you for those of you that have submitted questions about those. I hope it was helpful for me to walk you through why it missed the point or why it didn't. I'm always open to sharing more information about those with you guys, especially as you get closer to writing your own. If you don't understand why they missed a point and it seemed like a perfectly good response to you, definitely reach out to me. Let's have that conversation so that you are more likely to earn the point than the person who wrote that sample. And so again, we can go back to these, right? Here is what are common misconceptions about getting points for rows 7 and 8. And then of course, on the right-hand side of this table, what does a high scoring submission look like? And this is what you want to aim for over here on this right-hand side of this table. You want to aim for a high scoring submission. There was something else that I put in Google Classroom, or I shared with you, and that was the frequently asked questions that you guys gave me. So last week I asked you guys to watch a video about the Create, and then I gave you a Google form. It was just kind of like a silly thing, but just wanted to make sure that everybody understood some of the important aspects of the Create. And then I asked you guys to at the very, very end, do you have any questions for me? And I took all of the questions that you guys asked me, and I created a frequently asked questions document. And so in the frequently asked questions document, if you haven't already seen that, it looks like, let me see if I can find it really quick here. There we go. Looks like this guy. So how do I correctly code a citation? All of these answers I pulled from the College Board. So one of the things you can do, I don't know if you guys recognize this, but when you see these 2 forward slashes, this is actually how you comment in JavaScript. In Python, if you guys remember, the way we comment is we use a hashtag. So this would be a Python comment. So you can put the comment right into your code, right above wherever the code is that you need to comment. So if you're commenting to cite like an image that comes from somewhere, you can see they've got the bird image and then they've given a URL. But you could just make a comment that you got this code from, and then you could link that to wherever you found that code. So it could be a URL, and you can include the person's name. To the best of my knowledge, the College Board isn't as concerned with the way you are citing your materials. They're just concerned that you are. And if you remember in the Explore performance task, at the end in section 2E, you had to have so many sources for all of your research, and there were no rules about how to format those sources. They don't care about MLA or any of that stuff. They had sort of a template, but that wasn't something you were being graded on. So don't be too worried about that. There's also information in here. You guys asked about, do all the algorithms have to be created independently? What should we talk about? Do we talk about purpose or function? What is the due date? Can we use projects from previous years? Journaling, what is the journaling gonna look like? What are the relative percents that each one of these count toward your grade? So now that there's no exam, they're gonna go straight to 60% for the Create and 40% for the Explore. A few more questions about journaling. Someone asked me, what can this project be? Can it be literally anything? And the answer is yes, as long as it meets the requirements. So the requirements are in there. When should I start working on it, and how much help are we gonna get? So the answer is you probably wanna start working tomorrow. And the help you're gonna get from me today is gonna come in the form of some planning documents. So I wanna walk you guys through the first planning document that I'm gonna post in Google Classroom as soon as I get off this call with you guys. The first planning document just has an overview of what you need to do. So these are the 3 things you're gonna submit: a video of your program running, the written response to the prompts, and then a PDF of your code. So here's kind of a, I don't know, it's a little bit of a breakdown of how much time you should be allocating to each one of the tasks for the Create. And I put in like some windows that match up to the calendar I gave you. So this week, I'd like you to build a prototype. So really, you shouldn't be spending more than 1 to 2 hours building it. A prototype means that you've come up with an idea and you've sort of planned out your idea using pseudocode. So that means just writing out what are the aspects of your project that you need to create? Which functions do you need to build? What would that function do? You're not actually writing the code for the function yet. You're just sort of planning out what the structure or the skeletal structure of your program might look like. So develop a good enough prototype within 2 hours. That's just with the pseudocode. Start looking at it and evaluate, like, could I really build this next week? If I have 1 week to build this, is this realistic? Start looking at whether or not it's going to meet the responses for algorithm and abstraction. Have you made something that's complex enough that you can have an algorithm that has inside of it 2 sub-algorithms? Are you using abstraction, which you all should be because you're going to be writing your own functions? And I'm going to be releasing to you some more information to help you figure out, am I doing a good job writing my algorithm? Am I doing a good job writing out the abstraction? That's going to come on Monday next week. Right now, we're just working with outlining it, coming up with an idea and outlining it. So next week, the bulk of all this time, hours 3 through 7, is just coding. Next week is all coding, 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 coding. What I'd like you to do by next Friday, which is May 1st, is be completely done coding your project. What I want to tell you is that for the Create, you do not have to build a whole program. You can have the idea of a whole program, but then just build out one function in that program. That's all you have to do. In other words, if you think of this in terms of a Pong game, you didn't have to build a whole Pong game. You could have just, sorry, hold on. You could have just built just the paddle bounce function. And that could have been the only thing that you shared with the College Board. Now, it would have made it a little hard to show that actually running without having the other stuff there. But it's important that you don't think that you have to make the entire program with every little aspect of it working. So when I say code for a week, what's realistic? If you're doing too much, scale it back. So at some point the following week, I'll have you guys start working on making your video and writing your responses, and I'll walk you through these responses. And then the week before we get to the submission, way before the submission, oh, hold on 1 second. Okay, so then in the week of May 4th through the 11th, I'll give you days to write out your responses with, I promise, lots and lots and lots of information about how to write those responses well. And then in the week of May 12th through the 15th, that's like your finalization time. So looking over everything, double checking, I'll have a final checklist for you. You can edit your responses. You can keep coding if you want to. But remember that the coding is the video that you upload with the code in it that's actually working is 1 point. It is not a significant part of the grade of this. The writing is where all the points are, the writing. So do not go nuts trying to code and make this perfect program and then just, you know, blow off the writing at the very end. Like, I need to make my coding perfect, and then I'll just do the writing at the end at the last minute. That's the opposite of what you want to do. The coding can be really quick, right? I just built out this one function. I didn't have time to build a giant program, but I built out this one function. And now I want to write really, really well about this one function. And remember, that function is going to give us a chance to show abstraction. And then hopefully within that function, you have complex enough algorithms that you have a parent algorithm that has 2 child algorithms that work independently within that algorithm. And that you can write about one of them, at least one of them uses math or logic concepts. Okay, so that's sort of like a breakdown of our schedule. What I want you guys to work on today and tomorrow as you're moving forward is, what does your timeline look like? I know you guys have other classes. I know you're super busy. I don't know what else is going on with you guys. But I do think it's super important to be outside if you can, and be exercising and doing the other things that are keeping you guys healthy. So I want you to create your own timeline. What do you want to do? What's your plan? How are you going to work through this? So I sort of laid out where the hours are. These are sort of loose hours here: hour 1 and 2, hours 3 and 4, hours 5 and 6. We're not going to fill this all out totally, and I'm not interested in looking at what each of you are planning on doing, but I think it's a healthy thing for you, for yourself, to sort of plan out, how am I going to get this done? When am I going to get this done? So you can give yourself some due dates or days you're going to work on it. Whatever helps keep you on track. All right, here's the thing that is going to help you get actually started. This is the brainstorming part, okay? We spent a lot of time at the beginning of the year when we started our Explore tasks, just thinking like, well, what are you interested in? You guys remember I had you take out like little sticky notes and I put you in groups of 4, and it was like, write down something you're interested in. It doesn't matter. It doesn't have to be related necessarily to computers. But what would that be? And that's always a good place to get started, because if you're interested in building something that's personally relevant to you, it's a lot more fun. It'll be easier to start thinking of ideas. So if you're like, well, I'm super interested in astrophysics. I don't know how to write an app for astrophysics. Okay, that might be kind of a stretch. But what about a game that taught somebody about astrophysics? That's not a stretch. That's your passion. It's something you know a lot about. Turn it into a game. Make it super interesting. That could be true for any of your classes. I know you're not studying for finals. I'm sure you're very relieved about that this year. But I've had students in the past make games to help them study for their finals. So what would that look like? The purpose of the game doesn't have to have an educational purpose. It could just be the purpose of this game is to have fun. And that's okay too. Absolutely, a program can just have no purpose other than to entertain people. And that's totally okay too. But you should have a really clear purpose. So you should be able to say what the purpose of your program is in one sentence. What does your app do? That's functionality versus purpose. Purpose is for having fun or to entertain. But we also might want to talk about what does it do. So it might do something. Some of you asked about the difference between purpose and functionality, and that just depends on what your app is. If you make a calculator, I would argue that the purpose and the functionality are the same. It does calculations. That's both its function and its purpose. But it might be different depending on what you build. So we're going to talk a little bit about what it means to narrow it down. Repeat the narrow it down process with your own ideas. We want to have a first draft of our algorithm within 2 hours of starting to program. So that means that I kind of want you guys to be working tomorrow and Friday, and by Monday morning, I want to see sort of like a drafted outline of pseudocode showing me like, what does your draft look like? Do you know which aspects it needs to contain, even if you haven't written them or created them yet? I'm gonna say you probably don't want to build something that requires you to step way past where we've gone in this class. You don't want to say like, well, I don't know anything about this concept, but I'm gonna integrate it in my program. That's probably gonna lead to problems and stress you out. Remember, the coding is gonna be short, and then the thing we're really gonna work on, where all the work is gonna be, is in the writing. So you don't need to come up with anything new. It doesn't need to be flashy. You're not impressing the College Board with a program that can be sold in the in the App Store, okay? You're demonstrating what you've learned about programming through your writing. Keep the program simple. Spend your time, energy, and effort having really good writing. So I'm gonna ask you guys today to brainstorm some ideas. Just come up with a project or two. What could it be? What would the purpose be? Where could you see having an algorithm? Does it seem reasonable that you could do it in the next week? And do you have any concerns about the idea? These brainstorming tables that you're filling out, absolutely share these with a friend or a peer or a parent or me. you're just brainstorming ideas, and some of them might be a great idea, and some of them might be the kernel or the start of a great idea, and some of them might not be great ideas. So I gave you a couple places to jot some stuff down. Okay, so you don't have to fill out all 3 of these, but at least fill out 2 of them. What are some ideas that you have? Once we've sort of thought through some ideas, then we can narrow down those ideas. Okay, so I've already stressed this multiple times, but I'm going to stress it again. You are not going to have enough time to create the perfect project. 1 week of coding is not enough time for a perfect project. Okay, but that's okay, because you can still get full credit for a programming project that feels incomplete as long as it has working elements. So the elements that you're submitting to the College Board, if they are working elements, that's all you need. Okay, so you need 1 working feature that you can demonstrate in your video. One working feature. It does not have to be all the bells and whistles. But it will be helpful to think through what would the whole program look like. And now I'm just going to code this one part of it. That one part needs to be an algorithm that contains 2 subroutine algorithms. And then of course you need to show that you understand abstraction and that you can use it in your code. So here's how you're going to narrow down your idea. Split your project into individual components that likely require an algorithm that meets the requirements. In other words, your project should be a whole bunch of functions called by some main function at the end that calls all the components. Each of these components potentially could be your entire project. You don't have to build out every function in your project. You really only have to have at least 1. Okay, so pick 1 part of a bigger idea. Think about your project as a set of programming tasks that solve part of a larger problem. Some of these individual tasks could suffice for this project. So just pick 1 part from the larger idea and think about whether or not you can finish coding that 1 part in the time allotted. Minimal design mode. Even though it seems really exciting to have lots of visuals to make it really interesting, that is not something you're being graded on. So don't worry if it doesn't have sounds and flashing lights and explosions. It could just be a program that just prints stuff. You don't have to use simple GUI. You don't even have to use Python. So don't lose yourself in this idea that my program's terrible because it's not flashy, no bells and whistles. That's not what they're looking for. So once you have gone through your brainstorming and you picked 1 idea, I want you to tell me, how did you narrow down that idea? What's the algorithm you think you can use? And what is 1 part of the bigger idea of your program that you think you could make? All right. By Monday, I'm going to ask you to submit some pseudocode to me. So I'm going to put this Google Doc in Google Classroom, and I'm going to ask you guys to take a look at it today and tomorrow and Friday. And then I'm going to put out a document for you to submit some pseudocode to me and a project proposal. So it doesn't mean you're stuck. Once you submit your proposal to me, that's not the end of the world. You can continue to change your idea if you need to, but you should only change it if it's because you can't figure out a way to make it reach the requirements of the College Board. Next week is your only week to code. So now is the time to really think through all your ideas, pick 1, commit to it, and just stay with it and finish the coding so that the following week you can use your time to work on the writing. All right, so that's it for today. I hope this gives you a good idea of how to get started on your project. I tried to break it into chunks of time for you, even by weeks, and give you a way to get started with some ideas. And remember, we don't want to go nuts on our ideas. We want to narrow our ideas down, make them realistic to execute. This project is not about coding. It's about writing about coding. It's your job to demonstrate to the College Board that you understand algorithms and you understand abstraction. And the way you're going to do that is to write about your own creation. Okay? All right, you guys. So those are things that are going to be in Classroom today. Please take a look at them. I will continue to post resources for you guys. Each time we work on something, I've got materials for you so that you have something to work through. I've got lots of information about algorithms. I've got lots of information about abstraction. I've got checklists for you. I've got oodles and oodles of things to help you get organized. So I probably won't start posting all of those resources into Google Classroom until next week when you're actually starting to code. And most of them realistically aren't even for the coding part, they're for the writing part. But sometimes I think when you're coding and you're thinking through like, am I making this algorithm sophisticated enough to be able to write to? Sometimes I think having those documents as you're coding could be helpful. So I can post those in there too. And of course, if you have questions, if you're stuck on something, if you need help, if you're not sure if it's intricate enough of an algorithm, you can ask me to take a look at it. I might not be able to give you all the feedback that you want. But remember, this project is collaborative in nature, meaning you can ask a peer to look at your code and say, what do you think? Or how could I make this algorithm more sophisticated? Your peer can give you tons of ideas. There's nothing wrong with getting ideas from somebody, but the actual coding is what has to be done by you. And remember, the only coding that has to be 100% individually done by you is the code that you take a picture of and submit in your written responses. So if you get help coding other parts that you're not going to be submitting to the College Board or writing about, that's okay too. So don't feel like you're an island out there and you're doing everything on your own. You absolutely should use each other as resources if you need to and reach out to me. If it's something I can't help you with, I'll just tell you that's something I can't help you with, but there may be other ways that I could assist you in thinking through ideas on your own or getting started. All right, so that's it for the formal part of the presentation that I have to get you guys started on the Create Performance task. But I absolutely want to thank all of you for being here today. I hope everything's going okay. I'm thinking of you guys all the time. I'm sending you emails and wondering what's going on out there for all of you. So if you have questions, I'll stay on the call and continue to answer questions. Otherwise, thank you all for attending. If you don't have any questions, you can peel off and do other stuff that you need to do for today, and I'll post this recording in Google Classroom. Goodbye, everybody. Thanks for coming. It's good to see you guys.
Hi, Ms. Gilson.
Hi, how are you?
I'm good. I have to jump off the call really fast, but I was just wondering what to do. I'm not gonna take any of my AP tests. It's just, yeah, I'm just not going to. But I was just wondering, I'll still do the project, but could I make like a slightly more sophisticated program and then write about that?
You can make any program you want, Amelia. It's totally up to you. No one is saying don't make a sophisticated program. We're just saying here's the minimum.
Okay.
If you don't feel like you can do everything. So if you feel like, and I know you have the coding capacity to do it, I say go for it.
Okay, cool.
Yeah.
Yeah, thank you.
You're welcome.
Hi, Ms. Gilson.
Hi, Carly.
I just have one quick question.
Yes.
So I know for one of the algorithms, it says like function independently. Is that like, so one of your algorithms, does that mean it has to like function outside of it?
No,
So,
it means it needs to be a standalone algorithm on its own.
So that just means that like if you take it out, so it's like just a selection within one. Like, okay, my idea would.
If I took it out and removed it from my other algorithm, it would still be considered an algorithm.
Okay.
Got
so
enough code in it to be its own algorithm.
So I know for one of the ones that I was going over, the sample ones, I was confused. I think it was C. Like they didn't get the point for one of them, and I thought that might be why, but I'm not quite sure.
Okay, I can pull it up.
Yeah, I marked down the question and I didn't turn it in yet because I was waiting to ask it, so I'll pull it up and see which one it is.
Yeah, and I'll pull it up and we can take a look at it.
I think it's C.
Okay. You think it's C?
I think it's C. I'm checking right now.
Is it the one with the
Yeah,
little
it's
boat and the
C.
fish?
Yeah, it was C.
Okay, and row 6?
Yes.
So the requirements for row 6 is that the selected code implements an algorithm with 2 or more algorithms inside it.
Yeah.
And they show 3 algorithms, but the main algorithm, it doesn't include the other 2. They
Okay.
kind of show 3 separate ones.
Okay. So it's not like one algorithm containing 2 other algorithms.
Right.
It's just...
And one way you can think about it is like, if I pulled those out and those algorithms and I wrote them as their own function,
Mhm.
and then I called them inside my algorithm,
Mhm.
that would be one way that I would know that, number 1, they were a necessary part of the parent algorithm. Without those subroutines, the parent algorithm can't run.
Yeah.
And number
So-
2, I know that they can function independently because I wrote them as a separate function, and I evaluate that they use sequencing, selection, or iteration.
So would this like, okay, so iteration can just be like a function that has like steps. So it's like you're kind of like, it's just like a function. Would that work as iteration? Because it's like you're laying out the steps that it goes through, or not iteration,
Sequencing?
sequencing, yeah.
Yes,
Like-
but only if those steps have to go in that order.
Okay.
And not all code is written that way,
Okay.
right?
So I kn-
Like, not every bit of code that you write, like step 3 had to be written before step 4.
Okay.
That's
I
not
know-
always true.
Would
So
this,
you'd have to demonstrate that there was in fact sequencing,
Okay.
and you'd have to talk about why.
would
Why
this
was that
idea,
sequencing important?
would it work if I do like a battleship type game, and then like what I choose for this is like an if statement, like if it hit and if it didn't hit, then I have 2 different functions that run if it hit or if it didn't hit?
Yes.
Would that work for this idea?
Yes, that would be a
Okay.
great idea. And then you could have like your main function is just like the function that
Like the check function.
is like a check function.
And then you have the selection within that function, then you have the 2 separate functions that run if it
Mhm.
hits or if it doesn't hit. Okay.
Yeah.
Perfect.
Seems like a good idea.
Okay. Thank
Yeah.
you, Ms. Gillison.
You're welcome.
Bye.
Great day.
You as well.